There are two temperature scales in common use today. The Fahrenheit scale, based on a scale proposed by Daniel Gabriel Fahrenheit, is commonly used in the US, its associated territories, and several island nations in the Caribbean, making it essentially a de facto part of the US customary system. On the other hand, the Celsius scale, developed by the Swedish astronomer Anders Celsius, is the standard scale in the metric system. So to convert back and forth between the two, we have to do something a little different than just having kind of a straight conversion factor like we have in all the other measurements we've talked about so far. And the issue is this: 0 feet and 0 meters essentially mean the same thing, right? They mean an absence of length. It's the same thing with the other measurements. 0 liters and 0 gallons mean the same thing. Uh, 0 grams and 0 pounds mean the same thing. So, in a sense, all of those other scales have the same starting point, right? And because of that, we could just do our unit, our dimensional analysis. Everything works great. With temperature scales, that's not the case. 0 degrees Fahrenheit and 0 degrees Celsius don't represent the same temperature. They don't represent the same amount of heat that something has. So to convert back and forth between them, we're actually going to have some formulas. So the first formula I have here is the formula for converting from Celsius temperatures to Fahrenheit temperatures. Right? So if we know the Celsius temperature, we can put it in there for C, do a little arithmetic, out would come the Fahrenheit temperature. So to get a formula for the Celsius temperature, once we have this one in hand, all we really have to do is solve this for C. And if I do that, I can subtract 32 from both sides. F minus 32 equals 9/5 C. Then multiply both sides by 5/9. And we get C equals 5/9. So we need some parentheses here. F minus 32. Because it's the whole thing I want to multiply by that 5/9. Right? And that gives me my formula for converting a Fahrenheit temperature into a Celsius temperature. Right, so let's try a quick example here, right? The most commonly used baking temperature is 350 degrees Fahrenheit. And I want to know what is the equivalent Celsius temperature. So I want to end up with the Celsius amount. So I need the formula that starts C equals. And I'll put 350 in there for F. We should get our answer. C equals 5/9, 350 minus 32. And now you go to your calculator. This comes out to 176.67 degrees Celsius. And that really is how you should write temperature values, right? It's not uncommon to see people just say degrees and they kind of assume you know which of the two scales you're using. But a best practice really is to put a C or an F on the end so you make it explicit what it is you were trying to do. So what I want to know here is how many Fahrenheit degrees are there in 1 Celsius degree? In other words, if the temperature goes up 1 degree Celsius, how many degrees Fahrenheit would it go up? All right, well, here's how I'm going to approach this. Right, I'm going to start by saying that F1 equal 9/5 C plus 32. Right, then I want to know what is 1 degree higher? Well, what is 9/5 C plus 1 plus 32? All right, so if I subtract these now, I get F2 minus F1 is equal to 9/5 C plus 1 plus 32 minus 9/5 C minus 32. Right, so I subtracted the bottom one here from the top. All right, now watch what happens. I mean, first 32 minus 32, those go away. That's 0. So this is 9/5 C plus 9/5 minus 9/5 C. These 9/5 C's cancel, and I get a change, right? Because that's what this is here. This is the change in the Fahrenheit temperature of 9/5 of a degree. Right? So there's my answer. Right? 1 Fahrenheit degree is equivalent to 9/5 of a Celsius degree. Now, there's a second scale that's a part of the metric system, in addition to the Celsius scale. It's called the Kelvin scale, hence the K here. And it's actually very similar to the Celsius scale. A Celsius degree and a Kelvin degree are the same size. The only difference is their starting point. Now, unlike mass units where 0 grams means something has no mass, or volume units where 0 gallons means a container has nothing in it, 0 degrees Fahrenheit and 0 degrees Celsius aren't the lowest possible point in their respective scales. In both systems, it's possible to get temperatures that are lower. The reason for this goes back to chemists and physicists of that era not really understanding what heat was or where it came from. By the time the British Lord Kelvin came along, the nature of heat and energy was much better understood. So Kelvin was able to determine the actual point at which an object would literally have no heat. In technical terms, all of its molecules have stopped moving. That temperature, called absolute zero, is the 0 point of the Kelvin scale, and it occurs at negative 273.15 degrees on the Celsius scale. Since the Kelvin and Celsius degrees all have the same size, switching back and forth between the two just means adding 273.15 to a Celsius value to get the Kelvin value, that's the first formula, or subtracting 273.15 from the Kelvin value to get the Celsius temperature. So how can we convert Fahrenheit degrees into Kelvin? We don't have a formula for that, and we could come up with one, but we don't have one right now. So to do this, what I'm going to do is I'm going to take that Fahrenheit value, I'm going to convert it into Celsius, then I'm going to add 273.15 to it. It's another one of those kind of two-step processes. So the formula, Celsius equals 5/9 F minus 32. That'll give me the Celsius value. So if I put 160 in there, this is 5/9 160 minus 32. And according to my calculator, this is 71.11 degrees Celsius. So to get the Kelvin number, all I have to do is take that 71.11, add 273.15 to it, and we get 344.26 degrees Kelvin. Okay, so that's the end of our discussion of temperature. And in the next lecture, we're going to take a look at conversions with time units and see how we can go back and forth between those values.